Hi everyone, welcome to Edu-Malanga. We do video tutorials for Matric Math in South Africa. We're still working through Unit 1, that's patterns, sequences and series. And under Unit 1 we're looking at the second lesson, which is geometric sequences. Today we are doing the last example on geometric sequences. The last example will be example 3. And let's get right into it. In example 3, we'll solve the question, find the first 3 terms of a sequence where T3 is equal to 8 over 3 and T6 is equal to 8 over 81. So this is the first time we're looking at a question like this, but I'm glad we're doing it. If you see it in a test or in an exam, you'll know how to go about solving it. We'll get started by reminding ourselves of the general term for geometric sequences. The general term for geometric sequence looks like this. You have Tn, which represents the term number, so it's equal to A. A represents your first or your starting term of the sequence times R. R is the common ratio of your geometric sequence. When you have the starting term, for example, when you're looking for the next term in your sequence, you multiply the starting term by R and then you'll find the next term of the sequence, and R is powered to the power of n minus 1. This is the general term of a geometric sequence. We're going to use this general term to solve the question we've been asked in example 3. We'll start by using a substitution. We know what term number 3 is, so let's come back to the general term. We say T3 is equal to 8 over 3. That means that in term number 3 we know what Tn is equal to, and we also know that n is equal to 3. So we're going to substitute the known variables into the general term. The general term will then become T3 is equal to 8 over 3 is equal to A. We still don't know what A is, times R. We also don't know what our common ratio is. We know that n is equal to 3, and then 3 minus 1. We'll then simplify this expression over here. We'll have 8 over 3 is equal to A times R squared. We probably can't simplify the general term any further for term 3, but what we can do is we can perhaps make A the subject of our equation. Let's rewrite it on the next page. 8 over 3 is equal to A times R squared. In order to make A the subject of the equation, we're going to have to divide this side by R squared so that these two can then cancel out. And because we're dealing with an equation, what we do on this side of the equation, we also have to do on that side. So on this side, we're also going to divide again by R squared. That means we're going to have R squared at the bottom here. It's going to multiply the denominator, which is 3. The expression will then be A is equal to 8 over 3R squared. Let's come back again to the question. We've simplified for term number 3 and we've substituted it into the general term. Let's substitute term number 6 now into our general term. We're going to have T6, again we know what term number 6 is, it's 8 over 81, and we also know that n is equal to 6, so we're going to have 8 over 81 is equal to A times R to the power of 6 minus 1. We'll then be able to simplify the powers of R. We'll get 8 over 81 is equal to A times R to the power of 5. Now let's return to the simplification that we did for term number 3. When we substituted in term number 3, we were able to make a the subject of our equation, and we determined that a is equal to 8 over 3r squared. So in this expression, we can substitute 8 over 3r squared in where we are seeing a. This expression altogether would then become 8 over 81 should equal to 8 over 3r squared, which is what a is, times r to the power of 5. We've now got an expression where the only variable we're seeing is r. So let's solve for r then. We'll start by simplifying on this side. We're going to say that the multiplication by r to the power of 5 is going to get rid of the division over here, and we're going to have 5 minus 2, and then we're going to have r to the power of 3. So let's rewrite this expression then. We're going to have 8 over 81 is equal to 8 over 3 times r to the power of 3. 8 appears on both sides of the equation. So if we divide by 8 on this side and we divide by 8 on that side, the 8s will cancel out and we'll get 1 and 1 where we have 8. And if we multiply by 3 times 3 on this side, this 3 is going to be cancelled out. Times 3 on this side, we're going to have 3 times 1, which is 3 over 81. And if we come back, it's equal to only r to the power of 3. Equal to r to the power of 3. What we'll then do is to use our calculator. We're going to calculate the third root or the cube root of 3. And on your calculator, it's a root that has a 3 in front of it. So you're going to put this in. You're going to have 3 over 81. So the cube root of 3 over 81, that is going to be equal to r. That's how we're going to solve for r. And that's equal to 1 over 3. We've now found out what r is in the general term of our sequence. We still don't know what a is, but we do have an equation that actually helps us solve for a over here. A is equal to 8 over 3r squared. We can substitute in r and we can then solve for a. So let's go. A is equal to 8 over 3r squared. This expression will be, when we say r is equal to 1 over 3, it'll be 8 over 3. What we can see is that r squared actually divides 8 over 3. So if we say divided by r squared, that'll be equal to 8 over 3 divided by 1 over 3 squared. I've chosen to write it like this because it's very easy for us to divide fractions when we see them like this. We know that all we do is we swap the numerator and the denominator, then change the sign. Let's start by removing the brackets from 1 over 3 squared. The square is going to go into the numerator and it'll also go into the denominator. So what we're going to have is we're going to have a is equal to 8 over 3 divided by 1 squared is just 1 and 3 squared, that's 9. Again, when we have division, we simply swap the numerator and the denominator and we change the sign to a multiplication and then solve. So a is going to equal to 8 over 3 times 9 over 1. Let's simplify this expression. 9 can be divided by 3, so the 3 would cancel out. 9 divided by 3 is equal to 3. Then the denominator is completely gone, and our answer is a is equal to 8 times 3, which is 24. So a is equal to 24. We now have the a of the geometric sequence that we didn't know, so we can write down the exact general term of the sequence, where term 3 is 8 over 3 and term 6 is 8 over 81, and that general term is equal to Tn is equal to A is equal to 24, we've said 24 times R is 1 over 3 to the power of n minus 1. That's the general term of this sequence over here. We've been asked to find the first 3 terms of this sequence. We know what term 3 is, we were given. So let's write down what we know. Term 1, what's term 1? It's easy enough to find term 1. You simply read it off your general term. Term 1 is equal to 24. And what's term 2? Well, we don't actually know what term 2 is, so we're going to have to solve for it. And term number 3 we had over here, it's 8 over 3. 8 over 3. So the last thing we need to do to solve the question is find out what term 2 is, and we're simply going to substitute 2 in wherever we see n in our general term. So that'll be T2 is equal to 24 times 1 over 3 to the power of 2 minus 1. 2 minus 1 is just 1. Well, that's pretty easy. Then we have T2 is equal to 24 times 1 over 3. That's equal to essentially 24 divided by 3, and that's equal to the number 8. So term number 2 of the sequence is 8. We've now solved the question. We've got the first 3 terms of the geometric sequence that has T3 equals to 8 over 3 and T6 equals to 8 over 81. Thank you for joining us for this example. I hope you found it helpful. Join us again for the next tutorial video where we will start a new lesson, which is the sum of arithmetic sequences.